Hi, my name is Joel Matthew, UR15CS177, and today I am going to be explaining two sorting algorithms which are merge sort and quick sort. Both these sorting techniques use divide and conquer method. So let's see the program. So first we have the header file iostream and using namespace std. So the control shifts to the main function. So I have declared two arrays a and b and two variables I and n and also the other necessary variables. So I have implemented these two techniques using a menu driven program. So I have used while and switch case. So the user asks for his choice, either merge sort or quick sort. Merge sort has the time complexity of big O of n log n in its worst case, but it also has a space complexity of big O of n. And quick sort in the best time complexity, it has big O of n log n, but the worst time complexity is big O of n square. So let's see how this program is. So the first, if we have merge sort, then the user is asked to enter the number of elements and the array elements. So we go to merge sort function. So in this function, this is a recursive function. So it actually divides the array based on the position value. So first we have using we recursively call this function, and this function keeps dividing the array into sub arrays until the sub array contains only one element. So when the array contains only one element, it is obviously sorted. So then it calls once it divides the array into subarrays of having one element, then it calls merges function. So in this function, two subarrays are actually merged using a temporary array, and subsequently each of the subarrays is merged, and we get the sorted array. So for quick sort, we again ask the user for the number of elements and also the array elements, and then we call the quick function. So let's see, and in this quick function is also a recursive function which calls actually the part function, which is used for partitioning and sorting the subarrays. So actually in this quick sort, the either the last element or the first element is assumed to be pivot, and all the elements which have lower value are pushed to the left, and which have the higher value are pushed to the right. And this is used to create partition them into two subarrays, and this process is repeated recursively. So and in the end we display the sorted array for each of the cases. So let's see how the program runs. So as you can see, the user is asked for the choice. Let's do merge sort, and let's enter the number of elements as 5. Let's enter some elements. So as you can see, we get the sorted array. So in this, first position, which is first position value, which is 0, and first position, which is last position, which is 4. We find the mid value, which is 2. So this element, and from here we partition the we divide the array into two sub arrays, which may be this and this. So accordingly, we again based on the position, we divide the array until we get sub arrays having only one element, and then we subsequently merge the two sub arrays to get the sorted array. And let's do the same for quick function. Quick. So let's enter the same. Let's enter some values. So in this case, first we assumed either the leftmost element or the rightmost element as pivot, and accordingly we divide the array into two arrays, sub arrays. So if we assume 8, the last element as the pivot, then we uh, if we assume the last element 8 as the pivot, then the elements which are smaller than 8 are pushed to the left, and the elements which are actually greater are pushed to the right. So 2 and 5 will be pushed to the left, and 12 and 11 will be pushed to the right. Then subsequently for same case we do for 5 and 2, the same procedure is applied, and same for 12 and 11 we again apply the same position. So in the end we get the sorted array. So thank you for seeing my program.